1.1, we'll look at what are called linear equations in one variable. So, first of all, let's get familiar with the terminology that mathematicians like to use. What's the difference between an expression and an equation? Well, first of all, an expression is just a bunch of terms added together. It might be, let's say, 3x plus 2 minus x. Now, because you do have expressions, you can add or subtract and combine like terms, but you can't actually solve anything because there's no equal sign. Whereas in an equation, we might have something like 3x minus 1 equals 5. That is an equation because there is an equal sign. This can be solved and we can actually find a solution and find out what x equals, but only because there's an equal sign and we have an equation. So what we'll look at in this first section is we are going to look at what are called linear equations. When we say linear equations, what we're going to be looking at is equations that just have one x raised to the first power. So it'll be something like what we were just looking at, 3x minus 1 equals 5. Remember, if you don't see an exponent on our variable, like we don't here, remember it's a hidden 1. So we're only going to be looking at one variable, and we'll usually use the letter x, but we could use something else, and it's only going to be raised to the first power. Then the question is going to be, how do we solve an equation for a variable? Well, if we want to solve an equation for a variable, the idea is going to be to get that variable by itself. So how do we get the variable by itself so that we'll have something that looks like x equals some number? Well, the idea with equations is that you have to keep them balanced. So the idea is whatever you do to one side of an equal sign, you have to do to the other. So that's why we have a bunch of principles of equality, things that we can do to both sides of an equation that really don't change anything, that keep it balanced. So we can add things to both sides of an equation. We can subtract things to both sides of an equation. We can divide both sides of an equation by something, or we can multiply both sides of an equation by something. Whatever it is we're doing, we have to do to both sides, though, so that we can keep our equation balanced. You have to think of your equation as a set of scales on either side. If you do something on one side, you knock off the balance, so you have to do whatever you just did, the exact same thing to the other side of the equation as well. Now, if you continue along, you'll notice that there are a bunch of properties for how to solve equations, but I don't think you need a whole list of rules. What we'll do is we'll just go through these naturally, and it will follow probably exactly how you'd expect. So let's take a look at our first example. Our first example, A, has us looking at the equation. Let's see, 10x plus 5 equals 17. So the first thing is we're trying to solve this equation for x, and we want to get x by itself. Before we can even get into that x term, that 10x, I have to get rid of that minus 5 that's off by itself. So the question becomes, how do I get rid of a plus or positive 5? Well, to get rid of a plus or a positive 5, we're actually going to subtract a 5. But if you do that to one side of the equation, you have to do that to the other so that it maintains balance. So that will get rid of our positive 5 by canceling it out with a negative 5. But we still have that 10x on the left-hand side. We haven't done anything with that. And now on the right-hand side, we have a 17 minus a 5, which is now going to give us a positive 12. Now, the only thing I need to get rid of now is that 10 in front of the x. The question is, what's between the 10 and the x? Well, you don't see anything, but there's a hidden multiplication symbol. So, how do you get rid of or do the opposite of what we have here? Well, we have multiplication. So if I want to get rid of multiplication, I'm going to get rid of it by dividing. Dividing by what? Well, we're multiplying by 10. I want to get rid of the 10, so I'm going to divide by 10. But just like before, in order to maintain balance, if I divide one side by 10, I have to divide the other side by 10. So what that will do is that will get rid of my 10 in front of my x. So I still have my x on the left-hand side here, but that's all I have on the left-hand side. And on the right-hand side, I now technically have 12 over 10. There is a problem with this answer, is that it's a fractional answer that is not reduced. It can be reduced, and we want to reduce it. Well, 12 and 10 are both divisible by 2, so let's reduce it by a factor of 2. That will give us 6 over 5. And that's going to be our final answer because it's reduced. We do not need to turn it into a mixed number. What we're going to do is just leave it as an improper fraction as